Okay, so one more lesson on graph and quadratic functions. This is number 16, and we're graphing in factored form. Don't forget that we also call that intercepts form. It's called intercepts form because the function gives us the x-intercepts. So again, just in standard form, we had an ax squared plus bx plus c. And we use those to find our axis of symmetry. We are not going to do that here because there's no b. And we have another way to find our axis of symmetry. It does immediately give us our intercepts. So if you remember from the olden days, we're factoring. We set each factor equal to 0, and we solve by adding that p over. So if I see here in our first example, the -1, that gives me an x-intercept of +1. And this +2 gives me an x-intercept at -2. By the way, I forgot the p and q are our x-intercepts, which we also call roots, solutions, zeros, okay? And we can find the axis of symmetry because the axis of symmetry will also be in the middle, like in the between the two x-intercepts. So we can add them together and divide by 2. So if I take 1 and add that to -2 and divide by 2, 1 plus -2 is -1. So -1/2 is my axis of symmetry. Don't forget to put x equals in front because it is the equation of a line. So it must be an equation. If you look at number 2, the opposite of +3 is a -3. And it has it twice. So what that means is that this only crosses the x-axis one time, which means our vertex is on the x-axis. And the axis of symmetry, if I add the two -3s, I get -6 divided by 2, which is -3, which if my vertex is my x-intercept, remember that's also where I get my axis of symmetry. So x equals -3 is my axis of symmetry there. And for this last one, my x-intercepts are at +7, 0 and -1, 0. If I add 7 plus -1, 7 plus -1 is 6 divided by 2 gives me x equals 3 for my axis of symmetry. Okay, example number 1. Our key features, we have a at -2. It's a negative, which means my parabola opens downward, and I have a maximum value. Intercepts form gives me my intercepts at +2 and +3. Well, 3, 0 and 2, 0. And then I can add those together and divide by 2 to get my axis of symmetry. 3 plus 2 is 5/2. And while I like fractions for plotting points, we will go ahead and turn that into a decimal. So we have x equals 2.5 is my axis of symmetry. So I'm going to go to 1, 2, and halfway more. That's where my axis of symmetry goes. And if I substitute that 2.5 into my original equation, I'm going to get my vertex, my y value of my vertex. So I have x minus 3 times x minus 2. And again, we're substituting 2.5. All right, so 2.5 subtract 3 is a -0.5. And 2.5 minus 2 is a +0.5. And I have to multiply that times -2. So 2 times a half is 1, and negative times negative is positive. So that's a positive 1 times 0.5, so it's 0.5. My vertex is at 2.5.5. Here we go. Now, because I have my intercepts, my x-intercepts already given to me by my equation, I can plot the points 3, 0 and 2, 0, which are super close, but this is what my graph is going to look like. So use what your equation gives you. Okay, so there's a U try. So you should pause, try this one on your own, and then check yourself. All right, so my A is 1. It's positive, so my parabola opens up, which means my parabola has a minimum. I have an x-intercept at -1 and at +4. -1, 0, 4, 0. I can use those to find my axis of symmetry by adding them and dividing by 2. So -1 plus 4 is 3/2. Oh boy, more decimals. So we have an axis of symmetry at 1.5. Now remember, when I do this, it should look like it should be in between these 2 points. So I go to 1.5 and I draw my line, and I did a good job because it is in the center of these 2 points. Since I have the axis of symmetry, I also have the x value of my vertex. So if I plug that in, I have x plus 1 times x minus 4. And I'm substituting that 1.5. So 1.5 plus 1 is 2.5. And 1.5 minus 4 is negative 2.5. And then I multiply 2.5 times negative 2.5 to get negative 6.25. So here is my y value of my vertex. So I'll go over here, I go to 1.5, and then I go down to 6 and a little bit further, and now I have my parabola.